Today we're going to talk about finding the spontaneity of Gibbs free energy. Before we get started, I just want to remember you this little mnemonic for delta G, delta H, T minus delta S. This is get high test score. Get high test score. So when you remember that, it will help you remember Gibbs energy. Now, you're going to see this chart, which is negative, negative, plus, all this amount of chart, and you could technically memorize it, but I want to give you a little shortcut or use a little logic to help you remember the concept of this. Now, when we talk about Gibbs energy for the first chart, I think this is pretty easy to memorize, which is negative. And that comes from when delta H is negative. When heat leaves the system, it makes the overall system more stable. And delta S is positive from second thermodynamic law, where entropy and continue increase. And obviously, when you flip all the signs, this is when you get non-spontaneous, when it's plus, plus, minus, plus, plus, minus. This is when it's non-spontaneous at all temperature. Now, I want to focus specifically on the third and fourth line when it's minus, plus, plus, and spontaneous only at high temperature. Let's focus our energy to the right on the heating curve. And I want to focus specifically on here. Here I have a chart where the y-axis is temperature and x-axis is the heat. So as I increase the heat and at 100-degree temperature, this is when water is boiling. And so when water is boiling, what is delta H? Is delta H positive or negative? Positive, right? Because energy is entering the system, which is causing temperature to rise. And what is happening to entropy? Is it positive or negative? It's positive, right? Because when the temperature is high, the gas molecules want to, there's more chaos and disorder within that system. And so what we have to think about is when water is boiling, it is plus and plus. Now, my question to you is, does water boil spontaneously at high temperature or at low temperature? High temperature, right? Because you would not expect water to boil naturally at a cold temperature. And so when we go back to the third chart, when we see minus, plus, plus, just picture this as water boiling. And when water boils, it's only spontaneous at high temperature. Now let's look at the last line, which is negative, negative, negative. And that is the same thing as the melting curve. This is the same graph from above, but now it's in reverse. And we're going to focus specifically at 0. This is when water is freezing. And so when water is freezing, what is delta H? It's negative, right? Because heat is leaving the system. And what is delta H? It's also negative. Because when water becomes a solid, there's less chaos, less disorder within the water molecules. And so my another question for you is, when water is freezing, does it happen spontaneously at high temperature or low temperature? Low temperature, right? Because we expect water to be frozen at low temperature. And so when we see this last line, which is minus, 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 see this as water freezing. And we would expect water to freeze spontaneously only at low temperature. Hopefully this would give you some clarity, and hope this video helped. Thank you guys.